Chapter 24 examines the generalizability of study findings and how one assesses that, then does the same regarding importance. How do you assess whether a given finding is important? And finally, we develop a data interpretation model. Context, the interrelated conditions in which something exists. We can now go ahead and define generalizability. That is, the expected degree of similarity between the study result and the result that would be obtained if the study was carried out in a different setting or context. Perhaps at the risk of oversimplifying, if you expect similar results in a different setting, generalizability is high. If, on the other hand, you expect dissimilar results or don't have strong reason for thinking that results would be similar, then generalizability is low. And indeed, generalizability can be high to some settings and low to others. And we'll see that in some situations, degree of generalizability can be quite difficult to assess. We have two sets of tools that we'll use to assess generalizability. The first set of tools are those of inferential statistics, the procedures we've been studying in the second half of this text. What are the strengths and weaknesses of generalizations made using the tools of inferential statistics? Well, the upside is that given adequate sample size, the researcher can generalize with high confidence to the population from which the study sample was selected. For instance, the researcher can generate a narrow confidence interval. So if you've got a narrow confidence interval, you're quite confident of the results that you would obtain if the study could be replicated in the full population. So generalizations made using the tools of inferential statistics are ones we can have a great deal of confidence in. What's the downside? The downside to these generalizations is one can only use them to generalize to the population, if any, from which the random sample was selected. So that perhaps you do a random sample of students at your university and administer a survey, and then you generate some confidence intervals regarding opinions of students in response to the survey. Well, these confidence intervals, which are generated using inferential statistical tools, they tell you about the population from which your sample was randomly selected. So they tell you about the university population. They can't help you in drawing inferences beyond that population. And indeed, as we have discussed, in many situations, one study sample is not a random sample from any wider population. And in that situation, inferential statistics can't help you at all in judging whether there's good generalizability of findings beyond your immediate study sample. I'm going to mention something that's almost a technical note because it's part of perhaps more advanced stats, and that is that in the typical use of random sampling is to select persons to participate in the survey. But in some studies, random methods are also used to select, say, settings. For instance, which schools are going to be in our study? Or sticking with the educational setting, which classrooms within a school are we going to select to be in our study? Perhaps the persons who provide a given intervention could be randomly sampled. So if there is random sampling from units such as I've just described, then statistically based generalizations can also be made to the populations from which those units were selected. So if we selected a random a sample of schools within a given state, then whatever results we would obtain would statistically generalize to all schools in the state that were part of the population of schools from which we randomly selected our sample. So we're going to present a vignette here, in essence, to demonstrate the limited reach of generalizations made using statistical, which is to say inferential, tools. I'll read quickly. In January 1999, all 200 elementary students in super rural Oklahoma took part in a study on TV violence. 100 students were randomly assigned to a daily week-long 2-hour regimen of violent TV consisting of the shows Shoot 'em Up, Blow 'em Up, Blow 'em Up Every Which Way, and a couple of others. Mr. Macho facilitated this group. 100 students were randomly assigned to nonviolent TV shows, Best Friends, Share with Your Neighbor, Best Friends 2, and so on. Miss Peace facilitated this group. Both groups watched 20-inch TV sets from 9 in the morning till 11 in the morning. Observations of violent behavior during the lunchtime recess were made by trained observers using the PVOT, the Playground Violence Observation Tool. Statistical analysis indicated significantly more violent behavior in the violent TV group than in the non-violent TV group. Expressed in standard deviation units, the difference in means was 0.8 standard deviation units, and the statistical significance was at the 0.01 level. So let's put some of our knowledge to use, our data interpretation skills. The association between watching violent TV and aggressive behavior in our study is unlikely to be due to chance, and that's because the association was statistically significant. It's a reasonably large association, and that's because the difference in means of 0.8 standard deviation units is regarded as a large difference. And further, the association is almost without question a causal one. In other words, the difference in means between the violent and nonviolent groups is almost assuredly due to the intervention, that is, to the violent TV versus the nonviolent TV. The fact of random assignment has ruled out confounding variables. Now let's think about generalizing beyond the study sample. Our study sample is not a random sample. I mean, all 200 elementary students at super rural Oklahoma, all 200 of these are in our study. So to what wider population may we use statistical tools to generalize our findings? Well, there is no such population. I will mention that we can statistically generalize our findings, in essence, to an imaginary population, because when we carry out statistical significance tests, in essence, we're treating our sample as a random sample from a wider population. So we can generalize to an imaginary population of no real people, but on this earth, there's no real wider population to which we can statistically generalize our result. So let's ask some questions that pertain to generalizability. In other words, to whether we would obtain similar results in some different settings and in some different study conditions. So would we obtain the same results or similar results in 2017 rather than 1999? At Super Rural's junior high rather than in its elementary school? In the elementary school in a neighboring town? In a school in urban New York City? In a school with a predominantly African American population in the Deep South? Using a 70-inch TV? rather than a 20-inch one. Perhaps with a viewing session in the afternoon rather than in the morning, and let's make that intervention continue for 2 weeks rather than 1. With a different selection of violent and non-violent TV shows. Do the results generalize to facilitators beyond Mr. Macho and Ms. Peace? Would we get the same results if we used a different measuring instrument? We took our observations on the school's playground. Would we see the same results in play in the students' neighborhoods? And finally, we saw less violent behavior on the school playground. Would that carry over into the students' interactions with their family members? So, I mean, the point that I'm making now is that inferential statistics is not equipped to answer questions such as those disposed. Statistical generalization is limited to the particular context of the study and to the population, if any, from which the study sample was randomly selected. So, can we make any kinds of generalizations that go beyond the population, if any, from which the study sample was randomly selected? I take the position that yes, we can. We just simply need another set of tools. Statistical tools aren't going to help us make these generalizations. We need some non-statistical tools. And when you assess generalizability to a setting beyond the study context, perhaps the key tool in deciding whether generalizability is high or low to a new setting is degree of similarity between the study context and the context to which one seeks to generalize. The greater that similarity, the greater the expected generalizability. The less the similarity, the less the expected generalizability. Let's see how degree of similarity guides us regarding some of the questions posed in relationship to our vignette. Guided by the notion of similarity, we would expect greater generalizability, that is, more similar results, if we replicated our study in a neighboring rural Oklahoma town rather than in New York City. And that's because, I mean, the context, the setting, the conditions that the group of people in the neighboring town live in are presumably quite similar to those in super rural. So we'd have certainly an intuitive sense that we'd get more similar results, but I mean it really would be thinking through the degree of similarity that would be guiding us. So certainly we'd expect greater generalizability to the rural Oklahoma town. So the notion of generalizability goes not only to groups and populations, but it also goes to the different conditions that are part of the research study. The question might come up, would we expect similar results with a different selection of TV shows? Now, we didn't talk about how we selected the given shows for our study. Now, suppose that the shows that we selected are typical violent shows for the violent TV group. If we got a good, broad, representative, typical selection of violent shows, this might nudge our thinking towards the conclusion that the study results would have high generalizability across a variety of violent TV shows. In other words, that we could pick just about any set of violent TV shows, show them in our study rather than the ones that we actually did show, and that if we showed a different set of shows that we would indeed get quite similar results. Now, on the other hand, suppose that we hand-picked the violent shows in our study to be those that were particularly gruesome and violent. Well, then that set of shows is perhaps less representative of the, quote, typical violent show. So if that was the case, we would be hesitant to conclude that results would generalize well across shows. So we might, in this situation, expect lower generalizability of findings across different violent TV shows. And I just do want to point out that these are tough considerations. 1999 was the date of the study. Would we expect similar results in 2017? Maybe you're hearing this in 2017. I'm speaking in 2012. The world has changed in so many ways since 1999. This question is one that I think I actually won't answer here. So that's a tough question to answer. I mean, I guess I think that there is a commonality. If we're showing violent images, and these indeed lead to more aggressive and violent behavior in 1999, my thinking is such that perhaps the very same is so in 2017. So if our first set of generalizations were statistical generalizations, those based on statistical tools. So when we make generalizations that are made using tools other than those of inferential statistics, in other words, non-statistical tools, we are making non-statistical generalizations, and we are engaged in non-statistical generalizability. Degree of similarity is perhaps the key tool in making non-statistical generalizations, but it's not the only one. Now one factor that bears on generalizability is the characteristics of the study sample. In a very broad way, if you have a diverse, widely varying sample comprised of people with many different characteristics, as contrasted to a narrow, homogeneous file where many people have much in common. Well, if you've got that broad, diverse sample in a general way, that suggests that the findings may have a greater generalizability, or at least generalizability to a wider group of settings. Now, one thing that you can do is look at your study results and see if they hold within the different subgroups. As an example, do we see more violent behavior in our 1999 study for both girls and boys? Well, if so, the similarity of those results for girls and boys would suggest that study findings would generalize to both of these groups. But on the other hand, if we saw the result was much stronger for boys than for girls, we'd recognize that difference, and we'd recognize that we couldn't make blanket generalizations across both genders. Well, along with the degree of similarity, replication is at the heart of generalizability. So replication involves carrying out a study a second or third, fourth, or fifth time. Perhaps the key, the secret, if you will, to replication is that you carry out the study a little bit differently each time. That is to say, you strategically vary key study characteristics. For instance, in our TV violence study, perhaps we could carry out the study not in group watching of TV, as was the case in our study, but perhaps, and let's transform ourselves forward to 2012, let's have the kids watch these violent shows on their iPads or other computer devices. So we're changing the medium from TV to the iPad, and we are changing the setting from a group setting to one where the kids watch individually. So we're varying key study characteristics. So if we get a similar result, in other words, in our replication, if we still see that those who watch violent versus nonviolent shows are more aggressive, then that's suggesting to us that our results do indeed generalize beyond TV per se to different mediums of presentation of violent versus nonviolent content. That example was one in which our results continued to be the same. In other words, we saw more violent behavior in the violent iPad group than in the nonviolent iPad group. But perhaps we get different results. Perhaps in this newly carried out study, we don't see more violent behavior for those who watch violent TV shows on their iPads as contrasted to those who watch nonviolent shows on their iPad. So if you got findings that are dissimilar to those in the original study, when you vary the key characteristic, that suggests to you that the results may not generalize well across that key characteristic. And perhaps we do indeed carry out this study in a New York urban neighborhood with a predominantly African American population, and perhaps we do get a result similar to that in the initial study, so that the kids who see the violent shows in the New York neighborhood setting evidence more aggressive behavior than do those who see nonviolent shows. Well, so that's suggesting that our results may generalize across different settings, rural and urban. I mean, so strategically, I mean, the next thing might be, well, let's go ahead and replicate in some suburban settings. And if we saw, again, the similar result, that would build our confidence even more that the results generalize across different settings. But you see that the reasoning that we're engaged in is not statistical reasoning per se. It's much more logical thinking and calling on the notion of similarity and then building generalizability using replication, or sometimes the replication, as I mentioned, might suggest limits to the generalizability, or that generalizability differs to different settings. What is the upside to generalizations made using non-statistical logic? The great upside is that we can generalize beyond our study context and study population. So, for instance, you're carrying out some kind of intervention for violence in, let's say, Arkansas. Well, you can look at the Oklahoma results and you can say to yourself, I think there's a pretty good similarity between the setting that I'm involved in and the setting of that study. I think I'm going to do some similar kinds of things. I think that the things that I do to reduce violence have a good shot of yielding results similar to those in Oklahoma. So you see, you're not limited to the random sample. You're not limited to the population from which the random sample was selected. But you can generalize much beyond this. What are the downsides? One big downside, I think this is the key downside, is that you are drawing conclusions that go beyond your data. So the data in your sample, in conjunction with your sampling methodology, lets you use statistical reasoning to draw conclusions about the population from which you randomly sampled. You're sticking there to the context and the limits of your particular study and to your data per se, but when you generalize outside of the study population, in essence, you're making a leap of faith. You're using a non-statistical logic. So it's very important that generalizations that are made that are non-statistical and that go outside of the study population, these need to be made much more cautiously and tentatively than do statistical generalizations. Sometimes we've got replications in different settings, and so this can help a great deal in making an informed non-statistical judgment about generalizability. In other situations, there may be no study conducted in a context that is similar to the one in which you're engaged in. So you're kind of stuck with, you need to make your best assessment of the generalizability of the study finding to your particular context and situation. In my opinion, you do indeed want to make informed assessments, and you want to look in particular at degree of similarity to make some kind of a best guess of the results that might be obtained in your setting. But I think I like the term educated guess, because that's sort of I think a good one that it recognizes that there is often considerable uncertainty in non-statistical generalizations. So if I was to try to sum this up, I mean, statistical generalizations are made within one's data. They're quantitative. Basically, they provide reasonably precise answers, or at least answers in essence within the limits of the confidence interval. And you can make these in general with considerable confidence. On the other hand, your non-statistical generalizations are qualitative. They're in essence are best judgments or best guesses, and you need to be tentative with these and to recognize that you could be wrong. The text has a discussion in which a professor admonishes that one should never make generalizations beyond one's population from which the study was randomly sampled. I would modify that to say you should never draw statistical generalizations beyond that population, but that do need to reason cautiously and carefully and guided by the notion of similarity to draw some kinds of conclusions about generalizability to other settings. Okay, our next video examines how do we assess whether a given study result is an important